The thought of humanity living on another planet has captured imaginations for centuries. From the pages of science fiction to the halls of leading space agencies, the question has always lingered: can we truly escape the bounds of Earth and make another world our home? While this dream may have seemed distant for most of human history, advancements in science and technology are bringing the idea closer to reality. But the journey to colonizing space isn't just about reaching the stars, it's about survival, exploration, and redefining what it means to be human. Today, Earth faces challenges that threaten its ability to sustain life as we know it. Climate change, overpopulation, and dwindling natural resources are no longer issues of the distant future. They are problems unfolding in real time. This has spurred interest in finding solutions beyond our planet. The stakes are incredibly high. According to projections, Earth's population is expected to surpass 10 billion by the year 2100, a figure that raises urgent questions about how we will manage food, water, and energy for so many people. And that's just one of the reasons scientists and innovators are looking to the stars. But living on another planet isn't just about solving Earth's problems. There's something inherently human about the urge to explore, to reach beyond our grasp, and to imagine new possibilities. The first humans who looked up at the night sky thousands of years ago could hardly have imagined what we now know. We've identified over 4,000 planets outside our solar system, many of which lie in what scientists call the habitable zone, where conditions might support life. Still, these findings raise more questions than answers. What makes a planet habitable? How would humans adapt to living on a world with entirely different conditions? And, most importantly, how close are we to making this vision a reality? The journey to colonizing space is filled with both hope and uncertainty. It's a story of groundbreaking technology, unparalleled scientific discoveries, and the resilience of human ingenuity. But it's also a tale of immense challenges, biological, societal, and ethical. How do we ensure that space colonization benefits all of humanity and not just a privileged few? What sacrifices will be necessary to create sustainable settlements on planets like Mars? And perhaps the biggest question of all, is humanity truly ready to take this next giant leap? In this video, we'll dive deep into the science, technology, and controversy surrounding space colonization. From examining why we might need to leave Earth to exploring the planets most likely to become our next home, we'll uncover the latest research and surprising insights that bring us closer to understanding this monumental challenge. Along the way, we'll explore the cutting-edge technologies being developed to make interplanetary living possible, the psychological and physical hurdles humans must overcome, and the bold missions already paving the way for a future among the stars. This is more than a journey of scientific exploration, it's a journey of human survival and ambition. So, let's embark on this quest to answer one of the most pressing questions of our time. How close are we to colonizing space and living on another planet? Why leave Earth? The question of why humanity should consider leaving Earth is not merely a hypothetical one. It's a pressing matter tied to our planet's uncertain future. While Earth remains a remarkable cradle of life, mounting challenges are forcing us to think beyond its boundaries. From environmental threats to existential risks, the reasons for exploring other planets are deeply rooted in both necessity and ambition. The fragility of Earth's ecosystem. Earth, as abundant as it is, operates on a delicate balance. Over the past century, human activity has increasingly strained this balance, leading to consequences that are difficult to ignore. Climate change has become one of the most immediate threats, with global temperatures rising by more than 1.1 degrees Celsius since pre-industrial times. This warming trend is triggering catastrophic events such as extreme weather, melting polar ice, and rising sea levels, which threaten to displace millions in coastal regions. Adding to this crisis is the overexploitation of natural resources. A United Nations report highlights that humanity consumes 1.7 times more resources annually than Earth can replenish, a figure that underscores the unsustainable nature of our current trajectory. Coupled with deforestation, pollution, and the rapid extinction of species, it's becoming clear that Earth may not sustain human life indefinitely without drastic changes. Preparing for catastrophic events beyond environmental concerns, humanity faces risks from catastrophic events that could render Earth uninhabitable. Asteroid impacts, for example, are not just the stuff of Hollywood movies. They are scientifically documented threats. NASA has identified over 30,000 near-Earth asteroids, and while most pose no immediate danger, even a single impact could have devastating consequences. The asteroid that wiped out the dinosaurs 66 million years ago is a chilling reminder of our planet's vulnerability. Nuclear war is another potential disaster. As long as nuclear weapons exist, the possibility of large-scale destruction cannot be ruled out. Similarly, pandemics, like the recent COVID-19 crisis, show how fragile global systems can become in the face of rapidly spreading diseases. Although humanity has survived such crises before, their increasing frequency and scale are alarming. The human drive to explore, while survival is a compelling reason to consider living on another planet, exploration is an equally powerful motivator. Throughout history, humans have pushed the boundaries of what was once thought possible. From crossing oceans to climbing the highest peaks, exploration has always been at the core of our identity. Space is the ultimate frontier, and the idea of expanding humanity's presence beyond Earth taps into this deep-seated drive. The pursuit of interplanetary colonization isn't just about survival, it's about answering profound questions about our existence. Are we alone in the universe? What role does humanity play in the cosmos? Establishing life on another planet could provide new perspectives on these timeless mysteries. Carl Sagan, the legendary astrophysicist, once said, "The surface of the Earth is the shore of the cosmic ocean." Recently, we've waded a little way out, and the water seems inviting. The role of future generations Planning for humanity's survival on another planet is also an investment in future generations. By addressing these challenges now, we lay the groundwork for a thriving, resilient human species. Colonizing space could also inspire the next wave of innovators, scientists, and dreamers. Children born today might grow up to witness humanity's first steps on Mars or even participate in building permanent settlements. Leaving Earth is no longer just a dream. It is an evolving necessity shaped by the challenges of our time and the boundless opportunities that lie beyond. As we continue to push the limits of exploration, we are reminded that our planet, while extraordinary, may not be the final destination for humanity. Instead, it may serve as the first chapter in a much larger story of survival and discovery. So, why leave Earth? The better question might be, can we afford not to? The ideal planets for colonization. When considering the possibility of living on another planet, the first question is where we could realistically go. Not all planets are created equal, and finding one that can sustain human life is no small task. Scientists have narrowed down the options to a few celestial bodies within our solar system and beyond. Each presents unique opportunities and challenges, shaping the blueprint for humanity's potential future in space. Mars, the frontrunner for colonization. Mars has long captured the imagination of scientists and the public alike as the most promising candidate for colonization. Its proximity to Earth, an average of 225 million kilometers, makes it reachable with current technology. The planet also has several characteristics that make it attractive for human habitation. Mars experiences day and night cycles similar to Earth, with a day lasting just over 24 hours. Its polar ice caps contain frozen water, a crucial resource for sustaining life. However, living on Mars is far from straightforward. The planet's atmosphere is 95% carbon dioxide, and its atmospheric pressure is less than 1% of Earth's, making it impossible for humans to breathe or survive without protection. Mars also lacks a magnetic field, leaving its surface exposed to harmful cosmic and solar radiation. Average temperatures hover around -60 degrees Celsius, with extremes that dip far lower. Despite these challenges, scientists are actively researching ways to overcome them, from developing advanced habitats to creating self-sustaining ecosystems. NASA's Perseverance rover has already begun exploring the planet, searching for signs of past microbial life and analyzing soil samples for future use. SpaceX's plans to establish a human presence on Mars are even more ambitious. Elon Musk has repeatedly stated his vision of building a sustainable city on Mars within the next few decades, with the ultimate goal of making humanity a multi-planetary species. The Moon, a stepping stone to the stars. While Mars garners most of the attention, the Moon remains a critical destination for future space exploration. Its proximity to Earth, just 384,000 kilometers away, makes it an ideal location for developing and testing the technologies needed for deeper space missions. The Moon's surface is rich in resources, including regolith, which can be used for building materials, and deposits of water ice in permanently shadowed craters. NASA's Artemis program is already laying the groundwork for a permanent human presence on the Moon. The goal is to establish a lunar base that can serve as a hub for research and as a launch pad for missions to Mars and beyond. The Moon's low gravity also makes it an excellent site for constructing and fueling spacecraft, as less energy is required to escape its gravitational pull. However, like Mars, the Moon presents significant challenges. Its surface is barren and lacks an atmosphere, leaving it exposed to extreme temperature fluctuations and radiation. Lunar dust, known as regolith, is highly abrasive and poses risks to both equipment and human health. Despite these obstacles, the Moon is seen as an essential stepping stone for humanity's journey into the solar system. Exoplanets, the ultimate frontier beyond our solar system, the search for habitable planets focuses on exoplanets, worlds orbiting stars other than the Sun. Astronomers have identified over 5,000 exoplanets, with a select few residing in the so-called habitable zone. This is the region around a star where conditions might allow liquid water to exist, a key ingredient for life as we know it. Kepler 452b, often referred to as Earth's cousin, is one of the most intriguing exoplanets discovered to date. It is located 1,400 light-years away in the constellation Cygnus. Kepler 452b is roughly 60% larger than Earth and orbits a star similar to the Sun. While its surface conditions remain uncertain, its location in the habitable zone makes it a tantalizing prospect for future exploration. Proxima Centauri b, orbiting the closest star to our solar system, is another promising candidate. At just 4.2 light-years away, it is significantly closer than other exoplanets, but the distance still presents challenges far beyond our current technological capabilities. Reaching Proxima Centauri b would require advancements in propulsion systems, such as light sails or nuclear-powered spacecraft, that could achieve a fraction of the speed of light. Challenges of interstellar travel. Despite the allure of exoplanets, the reality of interstellar travel is daunting. Even the nearest stars are unimaginably far away. At the speed of the fastest spacecraft ever built, it would take tens of thousands of years to reach them. This makes exoplanet colonization a long-term goal that hinges on breakthroughs in physics and engineering. Moreover, exoplanets come with their own uncertainties. Without direct exploration, we can only infer their conditions based on limited data. Factors such as extreme temperatures, high radiation levels, and unknown atmospheric compositions could render even the most Earth-like planets inhospitable. Bridging the gap between vision and reality. Mars, the Moon, and exoplanets each represent different stages in humanity's journey toward living on another planet. While the Moon offers a nearby testing ground, Mars is the most realistic destination for permanent colonization in the near future. Exoplanets, though enticing, remain the ultimate frontier, requiring generations of technological advancements to reach and explore. The search for ideal planets is more than a scientific endeavor. It is a testament to humanity's resilience and ambition. As we continue to push the boundaries of exploration, we must confront the challenges and embrace the opportunities that come with stepping beyond our home planet. Each discovery brings us closer to answering the age-old question, where will humanity's next home be? Technological breakthroughs enabling colonization for humanity to live on another planet. Extraordinary technological advancements are not just beneficial, they are essential. The challenges of space travel, survival, and creating sustainable habitats are immense, requiring solutions that bridge the gap between science fiction and reality. In recent years, groundbreaking technologies have emerged, bringing us closer to achieving the dream of space colonization. Pioneering spacecraft for interplanetary travel. The first step in colonizing another planet is developing spacecraft capable of transporting humans and essential cargo safely across vast distances. Modern advancements in rocket technology have revolutionized space travel, making missions more feasible and cost-effective. At the forefront of these developments is SpaceX's Starship, a fully reusable spacecraft designed to carry large crews and payloads to destinations like Mars and beyond. Starship represents a leap in both scale and ambition, with the capacity to transport 100 tons of cargo in a single trip. NASA's Space Launch System, SLS, is another critical innovation. Designed for deep space exploration, the SLS will power future missions to the Moon and Mars, providing the heavy lift capabilities needed for long-duration journeys. Together, these projects mark a new era in human spaceflight, where interplanetary travel is becoming a tangible goal. Reusable rockets have also dramatically reduced the cost of space missions. SpaceX's Falcon 9 has demonstrated the ability to land and relaunch boosters, cutting costs by millions of dollars per launch. This shift has made space exploration more accessible, paving the way for both governmental and private sector initiatives. Life support systems, creating habitable environments. One of the most critical challenges of living on another planet is providing life support systems that ensure a continuous supply of oxygen, water, and food. On Earth, these essentials are abundant and naturally replenished. In space, they must be artificially generated and carefully maintained. The International Space Station, ISS, has served as a testing ground for such technologies. Oxygen generation systems like the Oxygen Generation Assembly, OGA, split water into hydrogen and oxygen through electrolysis, supplying breathable air for astronauts. Water recycling systems on the ISS can recover up to 90% of water from sweat, urine, and condensation, minimizing waste and ensuring a sustainable supply. Food production remains a significant hurdle, as transporting large quantities of food from Earth is impractical for long-term missions. Researchers are experimenting with growing crops in space using hydroponic and aeroponic systems. In 2021, astronauts aboard the ISS successfully grew and consumed chili peppers, demonstrating the potential for cultivating fresh produce in controlled environments. Terraforming, transforming alien worlds. Terraforming, or modifying the environment of another planet to make it habitable, is one of the most ambitious ideas in space colonization. Mars is the primary candidate for terraforming due to its similarities to Earth, but the process would require unprecedented technological advancements. Scientists have proposed using greenhouse gases to thicken Mars' atmosphere, thereby raising temperatures and potentially allowing liquid water to exist on the surface. Another concept involves deploying giant mirrors in orbit around Mars to concentrate sunlight and warm the planet. While these ideas are theoretically plausible, they face significant ethical and logistical questions. Would transforming another planet be a violation of its natural state? And do we have the right to alter a world we do not yet fully understand? The role of artificial intelligence and robotics. Artificial intelligence, AI, and robotics will play a pivotal role in enabling space colonization. Building habitats, exploring terrain, and conducting maintenance in harsh extraterrestrial environments are tasks well suited for machines. Boston Dynamics Robotics, for instance, have demonstrated remarkable adaptability in complex terrains, a capability that could be applied to missions on Mars or the Moon. AI systems can also enhance mission planning and resource management. Machine learning algorithms are already being used to analyze data from Mars rovers, identifying potential sites for water and other resources. Autonomous robots could construct shelters and infrastructure before humans even arrive, reducing the risks associated with early colonization efforts. Sustainable energy solutions. Energy is the lifeblood of any colony, and sustainable solutions are vital for long-term survival. Solar power is the most practical energy source for planets like Mars, where sunlight is abundant. NASA's InSight lander has demonstrated the viability of solar panels in Martian conditions, and future missions aim to scale up these systems to power entire settlements. Nuclear energy offers another promising solution. Compact nuclear reactors, such as NASA's Kilopower project, can provide consistent energy regardless of sunlight availability. These reactors are designed to operate safely and efficiently, making them ideal for powering life support systems and other critical infrastructure. Overcoming the challenges ahead. Despite these advancements, significant hurdles remain. Spacecraft must become faster and more efficient to reduce travel times and radiation exposure. Life support systems must be scaled up to sustain larger populations, and the ethical questions surrounding terraforming must be addressed. Each challenge represents an opportunity for innovation, pushing the boundaries of what is possible. Technological breakthroughs are transforming the dream of space colonization into a reality. From advanced spacecraft and life support systems to the potential of terraforming and AI-driven solutions, humanity is steadily building the tools needed to venture beyond Earth. These innovations are not just steps towards survival, they are milestones in our journey to become a multi-planetary species. As we look to the stars, we are reminded that technology is not merely a tool, it is the bridge that will carry us into the future. The human element. Colonizing another planet is not just a technological challenge, it's a profoundly human endeavor. While advancements in science and engineering are critical, the success of any interplanetary settlement ultimately depends on the people who inhabit it. The human element introduces unique biological, psychological, and societal complexities that must be addressed to ensure survival and thriving communities. Biological challenges of living on another planet. Human bodies are finely tuned to Earth's environment. Gravity, atmospheric pressure, and Earth's magnetic field have shaped our biology over millions of years. On another planet, these familiar conditions are absent, presenting profound challenges to human health. For instance, Mars' gravity is only 38% that of Earth. Extended exposure to low gravity causes muscle atrophy, bone density loss, and cardiovascular issues. Astronauts on the International Space Station, ISS, have experienced these effects, even during relatively short missions, highlighting the need for countermeasures. Radiation exposure is another significant concern. Earth's atmosphere and magnetic field shield us from cosmic and solar radiation. Mars, lacking a protective magnetic field, leaves settlers vulnerable to harmful radiation levels that can increase the risk of cancer and other health issues. Proposed solutions include constructing habitats underground or using radiation shielding materials, but these add logistical complexity. Moreover, human reproduction in space remains a largely unexplored area. The effects of reduced gravity on pregnancy and child development are unknown, raising ethical and medical questions about expanding human populations on other planets. Psychological challenges in isolation and confinement. Living on another planet means enduring extreme isolation and confinement. Mars, for instance, is an average of 225 million kilometers from Earth. Communications take between 4 and 24 minutes to travel one way, making real-time conversations impossible. Settlers will experience profound separation from loved ones and the broader human community, which can lead to loneliness, depression, and anxiety. Simulation experiments on Earth, such as the High Seas, Hawaii Space Exploration Analog and Simulation Project, have shed light on these challenges. Participants living in isolated environments for months reported increased tension, interpersonal conflicts, and stress. These findings underscore the importance of psychological support systems, such as virtual reality experiences to simulate Earth-like environments and robust mental health programs. Additionally, monotony and sensory deprivation are likely to be significant issues. A barren Martian landscape offers little variation, and settlers will need activities and stimuli to maintain mental well-being. Entertainment, education, and creative outlets will play a crucial role in ensuring psychological resilience. Societal challenges in building new communities. Beyond individual health, the success of a colony depends on its ability to function as a cohesive society. Establishing governance, laws, and social structures on another planet introduces uncharted territory. Who will lead? How will resources be distributed? What rights and responsibilities will settlers have? One major question is whether interplanetary colonies will operate as extensions of earthly nations or as independent entities. Current international treaties, like the Outer Space Treaty of 1967, prohibit nations from claiming sovereignty over celestial bodies. However, these treaties may not address the practicalities of managing a colony. Private companies like SpaceX add another layer of complexity, as their role in colonization could blur the lines between corporate and governmental authority. Ethical concerns also arise regarding who gets to go. Will space colonization be accessible to all, or will it become a privilege reserved for the wealthy and powerful? Ensuring diversity and equity in colonization efforts is critical to creating balanced and inclusive societies. Adapting culture and identity. Life on another planet will inevitably shape human culture and identity in profound ways. Over time, settlers may develop unique traditions, languages, and social norms distinct from those on Earth. Cultural evolution will likely reflect the challenges and opportunities of their environment. For instance, the limited availability of resources may foster a greater emphasis on sustainability and cooperation. Generational impacts are another fascinating aspect. Children born on Mars, for example, may identify more with their planetary home than with Earth. Their physiology might also adapt to Mars' lower gravity, creating physical differences that set him apart from Earth-based humans. Such developments raise intriguing questions about the long-term trajectory of humanity as a multi-planetary species. Humanity's resilience and adaptability. Despite these challenges, humanity has shown time and again its ability to adapt to new environments. From the harsh deserts to icy tundras, humans have thrived in conditions once deemed uninhabitable. The same spirit of resilience will be crucial in overcoming the difficulties of living on another planet. Developing solutions to these biological, psychological, and societal challenges is not just a necessity, it's an opportunity to redefine what it means to be human. Colonizing another planet will require innovation, cooperation, and an unyielding determination to succeed. It is a testament to the human spirit's ability to confront adversity and turn dreams into reality. As we venture into the cosmos, the human element will remain at the heart of our journey, shaping the future of life beyond Earth. Current missions and future projects. Humanity's pursuit of space colonization is no longer confined to science fiction. Around the globe, space agencies, private companies, and international collaborations are working tirelessly to turn the dream of interplanetary living into a reality. These efforts, spanning Mars missions, lunar exploration, and beyond, represent the cutting edge of human innovation and ambition. Mars missions, pioneering the Red Planet. Mars has become the centerpiece of humanity's quest to colonize another planet. Current and future missions are not only paving the way for exploration but also laying the groundwork for potential settlement. NASA's Perseverance rover, which landed on Mars in 2021, is a critical milestone in this journey. Equipped with advanced tools, Perseverance is analyzing soil and rock samples to detect signs of ancient microbial life. These findings are essential for understanding whether Mars could support life in the future. Adding to this effort, NASA's upcoming Mars sample return mission aims to bring collected samples back to Earth for further study. The The European Space Agency, ESA, is also contributing to this ambitious project. These missions provide invaluable data about Mars' environment, resources, and potential hazards, helping scientists design technologies and strategies for human habitation. Meanwhile, SpaceX is leading the charge in private sector exploration. Elon Musk's company is testing its Starship spacecraft, which is designed to carry humans and cargo to Mars. Musk envisions a fleet of Starships establishing a sustainable city on Mars within the next few decades. This ambitious timeline reflects the growing momentum behind private initiatives in space exploration. Lunar exploration, a gateway to the stars. While Mars garners significant attention, the Moon remains a crucial focus for space exploration. Its proximity to Earth makes it an ideal testing ground for technologies and systems needed for deeper space missions. NASA's Artemis program is at the forefront of these efforts. The Artemis I mission successfully demonstrated the capabilities of the Space Launch System, SLS, and the Orion spacecraft. Subsequent missions, including Artemis III, aim to land humans on the lunar surface for the first time since 1972. One of the primary goals of Artemis is to establish a permanent lunar base. This facility will serve as a hub for research and as a staging point for missions to Mars and beyond. The Moon's resources, such as water ice at its poles, are critical for sustaining human life and creating fuel for spacecraft. International collaborations are also playing a vital role. The Lunar Gateway, a joint project between NASA, ESA, and other space agencies, will be a space station orbiting the Moon. It will provide support for lunar exploration and act as a stepping stone for missions deeper into the solar system. International efforts, a global vision for space exploration is no longer the domain of a few nations. Today, countries like China, India, and the United Arab Emirates are making significant contributions. China's Tianwen-1 mission successfully landed the Zhurong rover on Mars, showcasing the nation's growing space capabilities. Meanwhile, India's Chandrayaan and Mangalyaan missions have advanced lunar and Martian exploration. The United Arab Emirates HOPE probe, which entered Mars orbit in 2021, is providing critical data about the planet's atmosphere. These missions highlight the increasing globalization of space exploration, fostering collaboration and competition that drive innovation. Private sector innovation. Private companies are reshaping the landscape of space exploration. Beyond SpaceX, companies like Blue Origin and Rocket Lab are developing technologies to support human presence beyond Earth. Blue Origin's vision includes orbital habitats and lunar bases, while Rocket Lab focuses on delivering cost-effective solutions for smaller payloads. Innovative startups are also joining the race, exploring fields such as asteroid mining, habitat construction, and life support systems. These ventures are expanding the possibilities for space colonization and demonstrating the potential of public-private partnerships in advancing space science. Future projects, charting a path to colonization in the next few decades, are poised to witness some of the most ambitious projects in human history. NASA's plans for a crewed mission to Mars in the 2030s represent a monumental step toward establishing a human presence on the red planet. Similarly, SpaceX aims to accelerate this timeline with its Mars colonization plans. Beyond Mars, concepts like Venus cloud cities and asteroid habitats are being explored. While Venus' surface is inhospitable, its upper atmosphere offers relatively Earth-like conditions, sparking ideas for floating colonies. Asteroids, rich in minerals, could serve as both resource hubs and potential settlement locations. Pioneering the future. The current missions and future projects in space exploration are more than isolated endeavors. They are pieces of a larger puzzle aimed at ensuring humanity's survival and expansion. Each step forward brings us closer to answering the question of how close we are to colonizing space. As international collaborations and private innovations continue to push the boundaries, the dream of living on another planet transitions from possibility to inevitability. The journey has begun, and humanity's future among the stars is unfolding before our eyes. Controversial insights and criticism. While the prospect of colonizing another planet is exhilarating, it is not without its share of controversies and criticisms. As humanity edges closer to realizing this vision, debates around its feasibility, ethics, and potential consequences grow louder. These discussions reveal the complexities and trade-offs inherent in attempting to become a multi-planetary species. The immense economic costs of colonization and space exploration and colonization come with staggering price tags. NASA's Artemis program is estimated to cost $93 billion by 2025, while SpaceX's Mars colonization efforts could run into hundreds of billions of dollars. Critics argue that these funds could be better spent addressing pressing issues on Earth, such as poverty, healthcare, and climate change. The high costs of space missions raise questions about who will foot the bill and whether the benefits justify the investment. Private companies like SpaceX claim to lower costs through innovations such as reusable rockets, but the scale of interplanetary colonization far exceeds the scope of current missions. The financial burden may ultimately fall on governments and taxpayers, sparking debates about the fairness of diverting resources from Earth-bound priorities. Environmental concerns, saving Earth versus colonizing space. Environmentalists often argue that focusing on colonizing other planets distracts from the urgent need to preserve Earth. They contend that Earth is already habitable, and our efforts should prioritize restoring its ecosystems rather than abandoning it. Space missions themselves are not free from environmental impact. Rocket launches release greenhouse gases and other pollutants into the atmosphere, contributing to climate change. Another significant concern is planetary contamination. Introducing Earth-based microbes to other planets could disrupt any existing ecosystems, however primitive they may be. Conversely, unknown pathogens from extraterrestrial environments could pose risks to humans. The ethical implications of potentially contaminating pristine celestial bodies remain a contentious issue. Inequality in access. Will space be only for the wealthy? The commercialization of space raises questions about who will have access to its opportunities. Space tourism ventures like Blue Origin and Virgin Galactic already cater to the ultra-wealthy, setting a precedent that interplanetary colonization could follow. If space colonization becomes a resource-intensive endeavor, it risks creating a divide where only the richest individuals or nations can participate. This potential inequality is particularly troubling when considering the ethical implications of who gets to leave Earth and who is left behind. Would colonization exacerbate existing social and economic disparities, creating an off-world elite while the majority remain on an increasingly strained Earth? Addressing these disparities will be critical to ensuring that space colonization benefits all of humanity, not just a privileged few. Ethical and philosophical dilemmas of terraforming. Terraforming, often touted as a solution to making planets like Mars habitable, raises profound ethical questions. Transforming another planet's environment to suit human needs could irreversibly alter its natural state. While Mars is currently considered lifeless, future discoveries of microbial life would complicate the ethics of terraforming. Would humanity have the right to disrupt another planet's ecosystems, even if they are simple or primitive? Philosophically, colonization also prompts questions about humanity's role in the universe. Are we caretakers, explorers, or exploiters of the cosmos? Some critics suggest that the pursuit of space colonization reflects a colonial mindset, mirroring historical patterns of exploitation and conquest. Reconciling these concerns with the practical need for survival and exploration is a challenge that requires careful thought and international consensus. Technological and safety risk. While technological advancements have brought us closer to colonization, they also introduce risks. Space travel remains inherently dangerous, with catastrophic failures such as the Space Shuttle Challenger and Columbia tragedies serving as sobering reminders. The technology needed for long-term habitation, such as life support systems and radiation shielding, remains unproven on the scale required for large populations. Moreover, the reliance on private companies for key missions raises concerns about accountability and safety standards. Unlike government agencies, private enterprises prioritize profit, which could lead to cost-cutting measures that compromise safety. Ensuring rigorous oversight will be critical to mitigating these risks. Alternative perspectives: should we stay and fix Earth? A growing movement suggests that humanity should focus on fixing the problems of Earth rather than seeking refuge elsewhere. Proponents argue that the resources and ingenuity needed for colonization could instead be directed toward renewable energy, sustainable agriculture, and reducing carbon emissions. By solving Earth's challenges, humanity could delay or eliminate the need for interplanetary settlement altogether. Others contend that colonization could serve as a backup plan rather than an escape route. They emphasize the importance of striking a balance between preserving Earth and exploring other worlds, viewing space colonization as part of a broader strategy for long-term survival. Balancing optimism and criticism. And while the criticisms of space colonization are valid, they must be weighed against the potential benefits. Colonizing another planet could serve as insurance for humanity, ensuring survival in the face of catastrophic events. It could also drive technological advancements and inspire a new era of innovation and collaboration. These controversies highlight the need for transparent discussions and inclusive decision-making. Space colonization is not merely a scientific endeavor. It is a societal challenge that requires ethical, environmental, and economic considerations. As humanity prepares to take its next giant leap, it must confront these criticisms with honesty and resolve, ensuring that the path forward is guided by both pragmatism and aspiration. How close are we? As humanity's ambitions to colonize space grow, the question shifts from if to when. While significant progress has been made in science, technology, and exploration, many hurdles remain before living on another planet becomes a reality. Determining how close we are requires examining the current timeline, challenges, and varying perspectives on what lies ahead. The current timeline, from planning to execution, and space agencies and private companies have outlined ambitious plans for interplanetary missions in the coming decades. NASA, for instance, aims to send humans to Mars in the 2030s as part of its long-term exploration strategy. The Artemis program, with its focus on establishing a lunar base, serves as a stepping stone toward this goal. A permanent presence on the Moon will provide invaluable experience in sustaining human life beyond Earth, offering insights into resource utilization, habitat construction, and long-term survival. On the private sector front, SpaceX is advancing at a rapid pace. Elon Musk has expressed his vision of landing humans on Mars within the next decade, with the eventual goal of building a self-sustaining Martian city by the mid-21st century. SpaceX's Starship spacecraft, currently undergoing testing, is central to this plan. Its capacity to carry both humans and large payloads is a game-changer for interplanetary logistics. Despite these bold timelines, experts caution against over-optimism. Space exploration is inherently unpredictable, and unforeseen challenges often delay progress. While advancements in technology have accelerated certain aspects, the complexity of interplanetary missions makes precise timelines difficult to guarantee. Remaining challenges: bridging the gap. The technical and logistical challenges of colonizing another planet are immense. Spacecraft capable of safely transporting humans and supplies to Mars, for example, must withstand months of travel through harsh space conditions. Radiation exposure during the journey is a major concern, as current shielding technologies are not yet adequate for prolonged missions. Developing faster propulsion systems, such as nuclear or ion propulsion, could help reduce travel time and mitigate these risks. Once humans arrive on Mars, survival becomes the primary challenge. Creating habitats that protect against extreme temperatures, radiation, and dust storms is crucial. Current designs focus on using Martian resources, such as regolith, to construct protective structures. However, scaling these concepts to support larger populations remains a significant hurdle. Additionally, the psychological and societal challenges of living on another planet cannot be underestimated. Mars settlers will face isolation, limited communication with Earth, and the need to establish new social structures. Addressing these human factors is as important as solving technical issues. Contrasting perspectives, optimism versus realism, and the timeline for space colonization varies widely depending on who you ask. Visionaries like Elon Musk envision rapid progress, driven by private sector innovation and public support. Musk's optimism is rooted in the belief that humanity must become a multi-planetary species to ensure long-term survival. His confidence in technological solutions and resourcefulness reflects an ambitious approach to overcoming challenges. Conversely, more cautious voices emphasize the need for patience and pragmatism. Space exploration is a complex endeavor that requires meticulous planning, rigorous testing, and international cooperation. Experts like planetary scientist Robert Zubrin argue that while Mars is within reach, achieving sustainable colonization will take decades, if not centuries. The balance between optimism and realism lies in acknowledging progress while remaining aware of the work ahead. While advancements in technology and funding have brought space colonization closer than ever, the journey is far from complete. The first steps, a measured approach to the path to living on another planet, will likely involve incremental steps. Establishing a permanent presence on the Moon is the logical starting point. The Moon offers a nearby testing ground for technologies that will eventually be used on Mars. Successful lunar operations will build confidence and expertise, paving the way for more ambitious missions. Mars, as the most realistic candidate for colonization, represents humanity's next great challenge. Initial missions will focus on exploration, resource identification, and small-scale habitation. Over time, these efforts could evolve into larger settlements capable of supporting long-term human presence. Exoplanet colonization, while an exciting prospect, remains a distant goal. The technological barriers to interstellar travel are immense, and current efforts are focused on identifying potentially habitable planets rather than reaching them. However, the search for exoplanets continues to inspire innovation, with missions like the James Webb Space Telescope providing valuable insights into distant worlds. A future within reach. How close are we to living on another planet? The answer lies at the intersection of ambition, innovation, and perseverance. While significant challenges remain, humanity has made remarkable strides in understanding and preparing for this monumental endeavor. The next few decades will be critical as nations, private companies, and international partnerships work together to turn science fiction into reality. The dream of space colonization is no longer confined to distant horizons. It is becoming a tangible goal within humanity's grasp. The progress made so far is a testament to human ingenuity, resilience, and the unwavering desire to explore the unknown. As we stand on the cusp of a new era, the journey to living on another planet is not just a possibility, it is an unfolding reality, with each step bringing us closer to the stars. What would life be like? Imagining life on another planet is both thrilling and daunting. While the realities of interplanetary living are shaped by science and engineering, the experience of day-to-day life will also reflect the cultural, social, and emotional aspects of being human. How would colonists adapt to their new environment? What would their daily routines look like? And how might life on another planet differ from life on Earth? Daily life on Mars, a glimpse into the future. The life on Mars would be unlike anything experienced on Earth. Martian colonists would likely live in tightly controlled habitats designed to protect them from the planet's harsh conditions. These habitats would include advanced life support systems to regulate oxygen, temperature, and pressure, ensuring survival in an environment where the atmosphere is 95% carbon dioxide and temperatures can plummet to -60 degrees Celsius. A typical day on Mars would involve maintaining these systems and contributing to the colony's survival. Tasks might include monitoring energy supplies, managing water recycling systems, and growing food in hydroponic or aeroponic farms. While automation and robotics could handle many routine operations, human oversight and adaptability would remain essential. One of the biggest challenges for Martian settlers would be the reliance on Earth for supplies, at least in the early years. Colonists would need to innovate and develop local resources to achieve self-sufficiency. For instance, extracting water from Martian ice deposits and producing oxygen and fuel from the planet's abundant carbon dioxide are key research areas. The role of work and leisure. While survival tasks would dominate early Martian life, work-life balance would still be essential for mental health and well-being. Colonists might dedicate significant portions of their day to scientific research, exploring the Martian surface, and testing technologies for long-term habitation. Over time, the development of industries, from mining to manufacturing, could transform Mars into a thriving hub of activity. Leisure and recreation would also play a critical role in maintaining morale. Virtual reality could provide a connection to Earth, allowing settlers to visit familiar places or enjoy simulated natural environments. Fitness routines would be essential to counteract the effects of reduced gravity, and communal activities like storytelling, music, or sports could foster a sense of community. Social structures and governance. Establishing governance and social norms on another planet presents unique challenges. Martian society would likely begin as a small, cooperative community, but as the population grows, more formal systems of governance would be needed. Would Martian colonies operate as extensions of Earth nations or as independent entities? How would laws be created and enforced in such a remote setting? Collaboration and adaptability would be key to building a functional society. Early colonists, selected for their skills and compatibility, would need to work closely together to resolve conflicts and make decisions. Over time, cultural practices unique to Mars might emerge, reflecting the shared experiences of its inhabitants. The evolution of culture and identity. life on another planet would shape not only how humans live but also who they are. The extreme environment and isolation would likely foster a strong sense of identity among Martian colonists. Over generations, new traditions, languages, and ways of thinking could develop, creating a culture distinct from Earth. For children born on Mars, their home planet would be a central part of their identity. These Martians might grow up with different physical characteristics due to lower gravity, potentially becoming taller or having weaker bone density compared to their Earth counterparts. Their experiences would shape how they view Earth, not as their home, but as an ancestral world they may never visit. Generational impacts. Building a new society. As Martian colonies grow, they will inevitably face questions about their future trajectory. Education will be critical, ensuring that children born on Mars receive the knowledge and skills needed to thrive in their unique environment. The development of arts, literature, and sciences will also play a crucial role in shaping Martian society, reflecting the creativity and resilience of its people. Over time, Martian society might diverge significantly from Earth's. The challenges of life on Mars, limited resources, reliance on technology, and the need for cooperation, could foster values centered on sustainability, innovation, and collective responsibility. These differences could lead to a distinct civilization, potentially changing humanity's broader cultural landscape. The psychological and emotional journey living on another planet would not only test physical endurance but also emotional resilience. The isolation, distance from loved ones, and unfamiliar environment could lead to feelings of homesickness and loneliness. Addressing these challenges would require robust mental health support systems, from counseling services to technologies that help colonists stay connected with Earth. At the same time, the sense of purpose and adventure associated with being a space pioneer could provide a powerful emotional boost. Colonists would be part of a historic endeavor, contributing to humanity's survival and expansion. This shared mission could create a profound sense of camaraderie and fulfillment. Life beyond Earth. A new chapter for humanity. What would life be like on another planet? The answer is as varied and complex as humanity itself. From the practicalities of survival to the evolution of culture and identity, life on Mars, or any other world, would reflect both the challenges and triumphs of the human spirit. While the specifics remain uncertain, one thing is clear: the colonization of another planet would mark a new chapter in human history, redefining what it means to call a place home. As humanity steps beyond Earth, the dream of living on another planet becomes not just a scientific pursuit but a deeply human one. It is a journey that combines survival, innovation, and the enduring desire to explore, offering a glimpse into a future where the stars are no longer out of reach. The dream of living on another planet has captured human imagination for generations, and today, it feels closer than ever before. As we stand on the threshold of this new frontier, the journey to colonize space is a story of both incredible potential and profound challenges. It is a narrative shaped by groundbreaking science, ambitious exploration, and the unwavering determination of humanity to venture into the unknown. Recap of humanity's progress. From the earliest days of space exploration to the development of reusable rockets and life-sustaining technologies, humanity has made remarkable strides toward becoming a multi-planetary species. Current missions to Mars, the Moon, and beyond have laid a solid foundation for future colonization. With agencies like NASA, ESA, and private companies such as SpaceX pushing the boundaries, the dream of living on another planet is evolving from fiction to tangible possibility. We've explored how Mars, the Moon, and even distant exoplanets present unique opportunities and challenges for colonization. From biological adaptations and psychological resilience to technological breakthroughs, the journey to space colonization is as much about survival as it is about redefining humanity's place in the universe. The challenges ahead. Despite the progress, significant hurdles remain. Colonizing another planet requires addressing fundamental challenges, from radiation exposure and resource scarcity to the psychological and societal impacts of living in an alien environment. Ethical questions about planetary protection, environmental concerns, and the equitable distribution of opportunities further complicate the path forward. Yet, these challenges are not insurmountable. Humanity's history is a testament to its ability to innovate, adapt, and persevere. Each obstacle overcome in space exploration adds to a legacy of resilience and ingenuity that defines our species. The bigger picture, a step toward survival and growth. Space colonization is not just about leaving Earth, it's about securing a future for humanity. Whether it's the threat of climate change, asteroid impacts, or other existential risks, having a foothold beyond Earth offers a safeguard for our survival. Moreover, the pursuit of interplanetary living drives technological and scientific advancements that can benefit life on Earth, from medical breakthroughs to sustainable resource management. Colonizing space also satisfies a deeply human desire to explore and understand. It's a pursuit that connects us to the larger universe, offering answers to age-old questions about our existence and inspiring future generations to dream bigger. As we look to the stars, the dream of living on another planet is no longer a distant fantasy but a vision within reach. The work ahead will require collaboration across nations, disciplines, and generations. It demands a collective effort to ensure that space exploration is inclusive, ethical, and sustainable. What lies beyond Earth is not just a question of technology but one of humanity's will to persevere and thrive. The journey to colonize space is not merely about survival, it's about creating a future where our species continues to grow, innovate, and inspire. The stars are no longer unreachable. With every discovery, mission, and breakthrough, we take another step closer to calling another planet home. As humanity embarks on this monumental journey, we are reminded that the essence of exploration lies not just in reaching new destinations but in the courage to dream and the determination to make those dreams a reality.